With this video, I'll show you how to connect a TensorFlow job that's being trained in Azure Machine Learning Compute. Connect that to PyCharm for debugging using minor changes to the training script. We'll have a local submission script, and then also we'll be using something called ngrok, which allows you to create secure tunnels with a public IP to your local PC. So let's walk through what that looks like. We'll start with our training script here. So this is a standard TensorFlow training script. You can see we're using Keras here, and I have some options that we're passing to the Azure Machine Learning Compute. But the changes that I make to the training script, like I said, are pretty minor. What we do is we have this if statement here looking for this PyCharm underscore debug parameter, this environment variable. Well, we'll set that with our submission script, but the reason we have it behind this if statement here is because then I can have this in my training script for this debugger. I don't need to change my training script and have a different training script if I want to debug it, and another one if I do. So we have this if statement, and then we're using pydevd underscore PyCharm. This is a package that PyCharm uses to do its debugging. And you could find details in the PyCharm documentation of how this works, how to connect it, and so on. But essentially, for our purposes, we'll do this pydevd underscore PyCharm dot set trace. And that set trace parameter will start the debugger. Now, this pydevd debugger works by the training script where it is running stops and creates a connection to our debugging host. In this instance, it'll be this local laptop. And we pass along that host name and the port to listen on. Now, we will be passing these as environment variables because those will be somewhat changing based on what ngrok gives us. One thing to note here, I set standard out to server and standard error to server as false. When I tested these out and had that on, I was getting so many messages back from the service that it slowed PyCharm down to where it's barely usable. Standard out and standard error are going to be captured anyway by Azure Machine Learning, so I don't need those streamed directly to my console here on my local PC. I'll still have those, still be able to review them, but for my debugger, I just turned these off here. Now let's look at our submission script. Our submission script is just a pretty easy script that we can run on the command line. This runs locally on whatever PC. All it's doing here is reinstantiating our experiment objects for Azure Machine Learning, passes in some script arguments, and then submits a TensorFlow job. We create an estimator and so on. Now you'll notice here I have this request.get from localhost. When I have ngrok running, we'll cover that in a moment, it creates a local web server, and I can poll that local web server to get information about the tunnels that have been created. So with these two lines, I am getting the URL and the port that my tunnel is listening on in the public internet, and then tunneling back to my local IP. And then in my TensorFlow estimator here, I pass in these environment variables that are used for my debug script. So this is where I set PyCharm underscore debug, and I also pass along the port and the host variables that we just got above by polling the local ngrok server. Another thing to point out, this TensorFlow script is also determining which pip packages and conda packages are installed. In order to debug, I also need to include this pydevd-pycharm and show a specific version. You'll get that from your run configuration setup, and we'll show you that now. If I go to my edit configurations, I'm actually doing a compound run configuration. The first thing it does is runs this debug submission script, and then it starts my remote debugger. The debug submission script is pretty straightforward. I just say, here's the submission script to run, some parameters to pass. Those parameters I've all coded into my script, and that's all it does. Now the remote debugger, when I set that, I give it a host name and a port name. The host name is not important. The only thing this host name does is changes what, or I should say, the only thing it seems to do is change what this debug server script above passes. But we won't actually be using specifically this. I just set it to localhost. This port, however, is important. Now, this is not the code that we will put in our training script. It's not the port we'll be directing to, but we need this port later for ngrok. So I'm using port 8000 here. I could set this to any port that I want to, as long as I have my ngrok tunnel set up to use that. And I mentioned before that specific pip install. You can see that here. Here's the version that the pip install needs. And so you can just copy that, put it in my TensorFlow estimator, and that will then install that pip package as it's building out a container. So to run the script, as I mentioned before, we need to start ngrok. Ngrok, if you go to ngrok.com or ngrok.io, it will bring you to this. It is a program that you run locally on the command line, and it creates a secure tunnel between your laptop and the ngrok servers. And then it will publish out a specific IP address or a web address that you can pass to other things, and then those will traverse that secure tunnel. So if you go to ngrok.io or ngrok.com and sign up, you can get a free account that will allow you to run 2 tunnels just for free and go from there. So the tunnels that I'll be using here, if I click over to my command line, I'm going to start ngrok by typing ngrok TCP 8000. This is telling ngrok create a TCP, a generic TCP tunnel that's tunneling to port 8000. And I'll run this script. And you'll see it creates a tunnel for me that is listening at 0.tcp.ngrok.io on port 12718. These 2 values are the values I need to pass to my training script. Going back to PyCharm, now we can start our debug run in PyCharm by hitting this debug. I submit train py and remote debug. You'll see I have 2 breakpoints enabled. One is just this. On this TensorFlow, this is on my local. And in my train.py, I have a breakpoint down here in the os.makeDirs step. But let me submit my debug run. Now this is starting our debug, and you'll see PyCharm surfaces up. We have 2 debug sessions running currently. One is for the local script and one is for the remote script. The local script, I hit this breakpoint. I wanted to point out that lines 31 and 32 here are defining this URL and the port. And those are what we had from ngrok earlier, is just the URL that I need to pass and the port. So you don't have to specifically specify these every single time. Instead, you start ngrok and then we pull to get those values. So I'll go ahead and resume that. And if we look at the console, you'll see the run was submitted to Azure Machine Learning Services. Now if I switch to my AML compute and look at the debug process we have there, you'll see it's waiting for a connection from Azure Machine Learning. Now, when the debugging script, the training script, communicates with our debugger, you'll see this changes here to show that we have connected to the PyDev debugger. It's also asking us, saying that we can't find train.py in the project. So what we want to do then, Typically, when you set up remote debugging in PyCharm, you specify here is the path on the server that it'll be running, and what on the debug side on my local host, where that script is. So you set up that mapping. With Azure Machine Learning Compute, you can see this path is very long, and it's actually unique for each run that you submit. So we can't specify that mapping directly. But what we can do here is if we just remember for the debug session, and then we auto detect, and it will say, oh, I see you have train.py in your project. This looks like these could be related. I click OK, and now it connects that script. So it's pretty easy workaround. In my run configuration, there was an option that I chose to automatically stop the script as soon as it was connected. So you can see here, we've hit a breakpoint essentially, even though it's not specified, because we have connected. If I go to my debugger, you'll see I have things here like batch size, the data directory, and so on. And just like I could with any debugger, I can resume my program, and now it hits my breakpoint that I've specified in my project specifically. And it's going through and saying, okay, create these. And I have access to, again, all of the objects and so on, like you expect for any debug setting. If I look at Azure, in my experiments for the workspace, I've specified a remote debug. And I can see all of the different runs that I've had of this remote debug. And I have one that's currently running. So this is the current debug session. And if I look in this, you can see I have, the optimizer, learning rate, and so on. These are all would match up if we compared with what I have in memory here on my debugger. If I resume here, then the training job will resume on the AML compute, and we'll go from there. And so this is an example of how you can connect PyCharm and Azure Machine Learning, specifically Azure Machine Learning Managed Compute. Now, the other compute options in AML, such as notebook VMs, you can also connect to those using PyCharm's SSH tunneling and remote interpreter feature. That's something that you can easily do with notebook VMs and so on. So there are many different options, and PyCharm and Azure Machine Learning work very well together.